welcome back to Introduction to Physics Labs. My name is Paul Eric, and today we're going to be doing Lab 1.2a, which is entitled Linear Motion. And so the purpose is to define what do we mean about the position of an object, the distance it moves, what is its velocity, and what is its acceleration. Number two, to be able to use three equations. So the how fast equation, the how far equation, and then the hybrid equation. And you'll notice that the hybrid equation is in blue, so that means it's not going to be on your exam. Then number 5 is to know what do we mean by positive and negative numbers when it comes to position, velocity, and acceleration. And then to be able to draw a velocity versus time graph and know what it means, and then to be able to draw a position versus time graph and to know what it means. So we're only going to be using one simulation today. So it's going to be PhET Moving Man. So go to the internet and find PhET Moving Man. And so then this is what you're going to see. And you'll notice that you've got 3 sliders that you can move, or you can, I believe you can actually type in the number here instead of using the slider. But the black one, and I'll let you play with it, so move the black slider back and forth and just see what happens to this person here. So that's going to then define what do we mean by the position of somebody. And you notice that his position is on 0 right here. Then we've got his velocity, so you can change his initial velocity. And then you can also change his acceleration by using this one. And notice that we can have, if I move the slider over here, we have positive numbers. And then if I take the slider and I'll move it back over here, I have negative numbers. So later we'll talk about what is the significance of positive and negative numbers. So if we go back to here, so the very first thing that you're going to do is move the position slider, and then what does it change about the man? Okay, then the next concept that you need to understand is what is position. So position is where you are located at. And then a distance that you travel is your change in your position. So let me just draw a line here. And let's say that you start at 2 meters. So this is where the guy starts out at. Okay, then let's say that he moves over to here, and then this is going to be 8 meters. So this is his final position. So then to figure out the distance that he moves, which is technically delta r, so the distance is his change in his position, and then all we would have to do is take 8 minus 2 is going to be 6 meters. So that's how far he moved. Okay, but what did I say? We're always going to be starting the guy at 0. Okay, so that means that this number here is always going to be a 0. So that means that really I'm just going to use the letter R to represent the distance that he moves. Technically the letter R is his position, but we're just going to use the letter R to represent the distance. Okay, now we're going to set the position and the velocity and the acceleration equal to 0 and then start the simulation. Let me just forewarn you, it's going to be boring, all right? So you might be wondering, why in the world would I even want to do that? But set the position, his velocity, which I'm going to say is the same thing as his speed. Later we'll find out that speed and velocity are not the same. And then also set the acceleration equal to 0, and then just see what happens there. Okay, now the more interesting one is going to be this one. So we're going to set the position to 0. The position is always going to be 0. And we're going to set the velocity to 2. Okay, and the acceleration to 0. So this time the only thing that we're changing is his initial velocity. And then start the simulation and describe how the person is moving. So there's a particular word that I'm looking for. And we're going to fill in the blank here. Velocity is going to control the what of an object. Okay, so think about what is changing whenever you're moving at a constant speed, a constant velocity. And then put that in here. And then there's a particular word I'm looking for if you, there is no acceleration, then you're moving at a what kind of speed. So that's what I'm looking for on that. All right, now we're going to define what exactly do we mean by velocity. So velocity is going to be distance divided by time. And so your velocity v is going to be the distance you travel divided by the amount of time it takes you to do it in. And this time we're going to set the velocity to 0, okay, but we're going to set the acceleration to 3 meters per second squared. So set the velocity to 0 and set the acceleration to 3, and then run the simulation. And then you should note that there's going to be a difference in the way that he is walking across the screen. And so how does that differ from when the velocity was constant and the acceleration was 0? So this time the velocity is 0, but the acceleration is something else. So what is different about how he is moving? And then fill in this blank. Acceleration controls the what of an object. So you can think of acceleration as being the master control knob that is controlling ultimately what this guy is doing. And then we need to have a formula for acceleration. So we're going to use the letter A for acceleration. And then now you might be tempted to say that it's velocity divided by time, the way that we did position divided by time, or distance divided by time. But you notice that there's a triangle in front of this. So it's triangle V over T. So it's your change in your speed divided by time. This is really, really important. So acceleration changes your speed. Okay, so that's the purpose of it. So those are the two definitions. So this is the definition of what we mean by speed. This is the definition of what we mean by acceleration. All right, let's take a break. And when we come back, we will go to part 2 of the lab.